Lesson 65, 10-6, trigonomic functions. A little acronym here for you, SOHCAHTOA. We'll discuss what that means here in a second. We are working, the trigonomic functions are basically relationships amongst angles and sides of triangles. Dealing with the right triangle again. We'll talk about the different trigonomic ratios, comparing side lengths of right triangles. But the big thing here is these three terms here today: sine, cosine, and tangent. Sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. You guys should know what hypotenuse means. We talked about what opposite is. The hypotenuse is opposite of your right angle. Remember when we did Pythagorean theorem, we drew an arrow from our right angle to our hypotenuse. Adjacent means next to or neighboring. Tangent is opposite over adjacent as well, and we'll talk about the equations and how to set these up to determine side lengths of right triangles. The trigonomic ratios to set them up, they're right here: sine, cosine, and tangent. Sine is opposite over hypotenuse, just like the vocab term mentioned. Cosine, adjacent over hypotenuse. Tangent is opposite over adjacent. Hence this SOHCAHTOA here. SOHCAHTOA, S representing sine, O representing opposite, H representing hypotenuse, Ka, C representing cosine, A is adjacent, H is hypotenuse, and then TOA, tangent, opposite over adjacent. So it's just a little acronym there to help you out. When you come down here and you need to determine, it says the sine of C. So you need to find angle C. This would be angle C right here. Sine, or sine of C is opposite over hypotenuse. So what you'd start off is saying is the sine of C, you're always starting with your angle, the sine of C equals, well, what is opposite of sides, or of angle C? Opposite of angle C is 24. Your hypotenuse, well, that is opposite of the right angle, which is 40. So you'd have sine C, opposite is 24, hypotenuse is 40, and that would be your trigonomic ratio for the sine of C. The only thing you would need to do there is reduce that ratio to 3/5. Example 2 is cosine Z. Cosine, mentioned above, is Ka. So C representing cosine. I'm going to start with my angle, the cosine of Z. So I'd start down in this corner. A represents adjacent. Adjacent is neighboring. Now, if you look at this, some people are like, well, I don't know if is 30 neighboring, is 24 neighboring. Well, remember what 30 represents. 30 represents your hypotenuse, which is opposite of your right angle. Therefore, 24 is neighboring. So 24 is adjacent. And then we have H, which is our hypotenuse. And we just talked about our hypotenuse here is 30. So you would have cosine Z is 24 over 30, reducing to 4/5. And lastly, the tangent of C. This is how tangent would work. Tangent is TOA. So tangent, O representing opposite, A representing adjacent. So I'd start out by the tan of C. Tan of C is the angle, basically the tangent angle C. So I'd start in this corner of our triangle. Opposite of C is 9. So opposite would be 9. Over A is adjacent. Remember we just talked about in example 2 that 41 is our hypotenuse. So adjacent of C would be 40. So you would have opposite over adjacent, so 9 over 40. 9 over 40 would not reduce, so that would be your trigonomic ratio. Now I want you to get in the habit of locating your tangent, cosine, and sine buttons on your calculator. Notice that in the instructions that we want to round to the nearest 10,000th using your calculator. So what you need to do is find the tangent button on your calculator. Once you find the tangent button on your calculator, push the tangent button. So you're going to push tangent, and then you'll put in your degrees, which is 85. So tangent 85, hit equals, and what do you come up with? Remember, round to the nearest 10,000th. Well, that is approximately 11.4301. Cosine. Find your cosine command. Push a cosine. Put in 21 degrees. Hit enter. Round to the nearest 10,000th. And we should come up with approximately 0.9336. We'll notice here we don't have tangent A, tangent Z. It actually gives you the degrees, which we need in order to solve for X in these next couple examples. In the next few examples, we're actually going to find missing side lengths, and it states that we need to round to the nearest tenth. Basically, what it says up in this right up here is that you are going to use the degrees given, so the angle given, along with X and the value that you know. So it would look something similar to this down in here in number 6. You need to determine, are you going to use sine, cosine, or tangent? Always start with the angle given. Here's the angle given, 35. Determine what you know. So from 35, I know what's opposite of 35, which is 8. I also know my hypotenuse. So what uses opposite and hypotenuse? So what uses the opposite and hypotenuse? And you should have come up with sine. Okay, so katoa. Sine is opposite over hypotenuse. How you would set this up is you take your angle, the sine of 35 degrees, equals opposite over hypotenuse. Opposite is 8, hypotenuse is x. So now you have your equation set up that we need to solve. The next step here would be find the sine of 35 degrees. And remember, when we find the sine, cosine, and tangent, we've been rounding to the 10,000th. So 4 decimal places. Sine of 35 is approximately 0.5736 equals 8 over x. Solve for x. In order to solve for x here, x is the denominator. We need to get x off the bottom. In order to do that, it's dividing by x here, so I would multiply by x to both sides. When you multiply x to both sides, we get rid of x on the right side of the equation, leaving us with x times 0.5736 equals 8. Get x alone. In order to do that, we divide both sides by 0.5736. And you'd find that x is approximately, and remember the direction state to round to the 10th, so x is approximately 13.9. Example 7, start with your degrees. So we have degrees of 49. What do we know? We know what is adjacent to it, and we know the hypotenuse. So adjacent and hypotenuse. So katoa. What is adjacent and hypotenuse? We should come up with cosine. So ka. Start with your angle. Cosine 49 degrees equals adjacent, which is x, over hypotenuse. So adjacent x over hypotenuse 7. Find the cosine of 49 degrees. Remember, round to the nearest 10,000th. 0.6561 equals x over 7. Get x alone. Multiply both sides by 7. And we find out x is approximately 4.6. And this should, the biggest thing here, just a way to kind of think that your answer is correct, is this should be less than 7. Why should it be less than 7? Because 7 is our hypotenuse. It is side C. It is the longest side of the triangle. 8. We have 41 degrees. From 41 degrees, we know opposite and we know adjacent. So we have opposite and adjacent, so we would use TOA, which would be tangent. So we will use our tangent command. So we'll start out with tangent 41 degrees. Tangent is opposite, 10 over adjacent, x. 10 over x. Find the tangent of 41 degrees. Again, round to the nearest 10,000th, which is 0.8693, equals 10 over x. Solve for x. In order to do this, get x off the denominator. Multiply both sides by x. When you do that, we have x times 0.8693 equals 10. Get x alone. Divide both sides by 0.8693. And we find out that x is approximately 11.5. This concludes your lesson here on lesson 65, 10-7 trigonomic ratios.